I don't normally talk during these, but this is the first time you've seen this kind of problem. So I think if I did it all by just doing pop-ups, it wouldn't work. I need to just explain this to you as we go. All right, so this is a gold standard problem. We'll work one of these in class probably tomorrow, maybe, just so you have more practice. Maybe Wednesday, so you have more practice. But this is a good one to practice on. So gold standard is it can handle any kind of problem, any kind of physics problem really can be handled with gold standard, even if the units are crazy. All right, so it's a red kinematics equation to determine the speed of the moon. All right, so what I'm going to do is I'm going to circle all the given stuff so I can go back and use it. I'm not going to give you anything given that you're not going to use. Okay, so start off, that's kilometers per second. That's what I'm trying to end up in. So I'm going to go right over here and put kilometers per second right off the bat. Because that's what my answer is going to be in kilometers per second. Okay, so needed information. We're trying to figure out how fast the moon is traveling around the Earth. And if you look up at the moon, it doesn't look like it's moving at all, but that's because the distance is so far away. And we'll discuss that as well. All right, so the moon is 24,000 miles. That's the radius out from the Earth out to the moon, center of the Earth out to the moon. Time it takes the moon to orbit the Earth, 20 to 3 Siggies, 27.3 days. And then we have some conversions. I'm not going to give you any conversions that you're not going to use. I'm not trying to trip you up. So all of those things there we will use in our problem. Now the first thing then you want to do is once you've done that, is go to the start and let's go to this required drawing. And it's a pretty simple drawing. Nothing fancy here. Here's the Earth. Here's the moon. It's going in a circle, or it's really elliptical, but pretty much. There's the radius. So this is 20. This is the R at 240,000 miles. Then what else do we know? We know that the speed of the moon is. We know the period. Now the period's 27. That's a special time, and so period it is t, but I use a capital T with a little p there. It means a special time, and it's p for period. We have to distinguish the capital T because it also means something else in physics. So 27.3 days is how long it takes. And what else do we know? We have our conversions. Okay, so that's enough. And the question is, what is my velocity? All right, now we go over here to symbols. And so the one you'd think you'd want to use is, of course, delta x. Well, you have two red equations, right? We have the graphic version, which we're not graphing here, but we have the equation version. So delta x equals v times t. Thing is, though, it's not delta x, right? Because the moon's not going in a straight line, so it's going in an arc. And so we really have delta s equals v times t. And then we know that delta s, as it goes around in its arc, if it goes all the way around, one complete revolution, we know that distance, that delta s is 2 pi r. And we know that this being r. And we also know that occurs in the period t. So really, v then is delta s over that period, over TP. So now I come over here, I have my equation. V is equal to delta S. Whoa. Okay, let's go ahead and make that the way it should be. Delta S is true, but I'm going to say 2 pi r, that is delta S. 2 pi r over TP, okay? Now I come down to these boxes, and these boxes here are important because that's your symbols. And to get your symbols right, then put your numbers in. People try and get ahead of themselves all the time. I know, especially you fast thinkers, you're trying to think through it and get it all done in 2 steps. But for the harder ones, this is easy, but for the harder ones, that's going to be really hard to do. So put R, I put 1 over TP there. Okay, so see with that, all it does is I broke it up. Then I'm gonna go and put the numbers in here. This is 2 pi over 1. R is 240,000 miles, M-I, not M, M-I. And then the period is, it's 1 over the period. I mean, it kills me that students do it right here and they do it wrong here. Like they see the TP and they stick TP down there. Then they don't invert it. You have to reverse it. You have to put it on bottom. So that's 1 over, it's a reciprocal, right? 1 over 27.3 days. D, just plain D stands for days, but we use little d for something else. So now I'm going to change my color up. I'll make it purple, the givens. Now we got the givens. Those are all the givens. Now we're going to go to, okay, so all of these, this is always the givens. And then when you see that squiggly line, you're done with givens. So these are the givens. And then these are going to be the conversions. I'll make these in purple, but conversions. So normally I don't show you how many conversions you need, but this is your first time through a fairly a decent little problem. So I'm going to go ahead and show you the slots. Remember, this is the slot, slot, slot. These are cells, each one of these. 2 cells make a slot. Okay, so here we go. In purple, I'm going to go for conversions. And it doesn't matter which one you convert first. You know you're going to use these up here at some point. So you might as well go for those. I'm going to put miles on bottom. And I'll put 5280, 5,280 feet in a mile. See, I put the mile on bottom because I wanted to cancel. Bring out my green kill pen. Miles and miles cancel. Feet I still have. I want to get rid of the feet now. So I put 1 foot under 0.305 meters. And now the feet kill. Let's see now. Look, so I'm trying to end up in kilometers, so I'm hoping you know this. There are 1,000, something they've been teaching you, I hope, since probably 5th grade. There's 1,000 meters in a kilometer. You might have forgot because you don't do it very often, but all right, you won't forget it here. You'll do it enough. Kilometers I'm going to circle because I'm going to protect it. I'm going to kill the meters. So I got one of the units I want to end up with. Now I got to have seconds. All right. Go to my days, and I see the 27.3 days there. Okay, now let's get rid of days. So one day is 24 hours. Everybody knows that. To 2 siggies anyway. Green kill pin, day cancels. I don't want to have hours on my answer, so I go, okay, there's an hour. Now there's 60 minutes in an hour. You go, well, you didn't give us enough slots. Well, this is one combo that we do allow because it's so common. There's 60 minutes in an hour. There's 60 seconds in a minute. 60 times 60 is 3,600. So 3,600 seconds. Now, green kill pin, hour, seconds is saved, and voila. All you have to do now is multiply all the top numbers, then multiply all the bottom numbers, and then that's your answer, number-wise. I'm not going to bore you with me multiplying, so I'm going to pause it for a second, and then I'll come back and finish up. So I'll make it a habit of just writing the numbers down below. Now, there's no reason to put the units on these. I've already dealt with all my units. I know I'm ending up in kilometers per second, but I like to write all the numbers out just to make sure. And I can find some shortcuts here. Notice that, for instance, we can do a green kill pin on numbers too. 1,000, that goes away. So I don't need to worry about that 1,000. 528, I'm just being lazy here. And kill that last 0. That's all legal. And I think that's all I can do. Maybe I can kill another. No, I think that's probably it. You got to count from the left. I mean, not all zeros mean the same thing. You can't just arbitrarily kill zeros. But if you're reading from right to left, you can. So now let's go through. I'll punch in those numbers. So, and I'll pause it and come back. So I get, once I do you gotta be real careful. I mean, I hesitate. Thought about going back and changing up so you don't see me doing this, but I'm being lazy. Plus it gives you smaller numbers to work with in your calculator. But this is very dangerous. Be careful, because I get rid of the at the ones position, I get rid of the ones, tens, and hundreds positions. You can do that. But I couldn't take like that 0 and get rid of that 0. So anyway, that's pretty tricky. But you're going to get the same answers either way because it's a ratio. Anyway, so those are the numbers I get, and now I take that 2, 4, 2, 8, 4, 3, and divide that by 2, 3, 5, 8, 7, 2, and I get 1.03. 3 siggies is probably enough. 1.03 kilometers per second. That's a nice number to remember. So the moon's moving at about a kilometer a second. And then when you go out in the night sky tonight, take a look, and it doesn't look like it's moving at all, but it's moving in kilometer seconds really fast. You know, I'd be at the Warren Theater in about 10 seconds. So with that from Norman. Okay, there it is. I've gone too long, but there it is, worked out. I hope you try it first before you just kind of copy down. The idea here is that you're trying these things, you pause it, you try a little bit, you pause, but you end up getting it right. All right.